You might have come across a cylinder in your daily lives. A plumbing pipe is the simplest form of a cylinder. A cylinder has two dimensions, radius r and height h. Let us cut and open a hollow cylinder along the dotted line. It is a rectangle. When we open a hollow cylinder, the base opens into the length of a rectangle. So, the length of this rectangle is represented by the perimeter of the circle that forms the base of the cylinder. So, the length is 2 pi r. And the breadth of this rectangle is same as the height of the cylinder. So, lateral surface area of a cylinder is equal to area of this rectangle, which is length into breadth, or L into h, or 2 pi r into h. Let us look at the total surface area. The cylinder consists of this rectangle along with the two circles, one at the top and one at the bottom. The areas of these circles would be pi r square each. Let us substitute the value for lateral surface area. The total surface area of the cylinder is 2 pi r times h plus r. Let us see how to find the volume of a cylinder. Similar to a cuboid or a cube, let us stack the base h times. We could also write this as area of base times h. Since the base is a circle, the area of this base would be pi r square. Hence, volume of the cylinder would be pi r square h. Let us look at a problem. A soft drink is available in 2 packs. A tin can with a rectangular base of length 5 cm and width 4 cm, having a height of 15 cm, and a plastic cylinder with circular base of diameter 7 cm and height 10 cm. Which container has greater capacity and by how much? Let us draw a tin can with a rectangular base. It has a length of 5 cm, a width of 4 cm, and a height of 15 cm. Now let us draw a plastic cylinder with circular base. It has a diameter of 7 cm and height of 10 cm. Now let us compare the volume of these two objects. We shall find the volume by multiplying the area of base into height. So for the cuboidal pack, it shall be length times breadth times height. And for the cylindrical object, it would be pi r square times h dash. Let us call the height of the cylinder as h dash, since h is taken by the cuboidal pack. Let us substitute the values and calculate. We find out that the cuboidal pack has a volume of 300 cm3. Volume for the cylindrical pack is 385 cm3. Clearly, the cylindrical pack has a greater volume than the cuboidal pack. The question says by how much? Let us subtract. The cylindrical container has a higher capacity by 85 cm cube. Let us look at another problem. An open cylindrical vessel of height 2 meters can hold 30.8 liters of water. How much sheet of metal would be required to make it if 1/12 of the metal sheet is wasted? We are given that 1 liter of water is equal to 0.001 meter cube. Let us draw the object. It's a cylindrical vessel, which means it has a base, but it does not have a top. It has a height of 2 meters. We are not given the diameter. However, we are given the volume as 30.8 liters. Let us convert this into cubic meters. Since we know that the volume of a cylinder is pi r square times h, let us equate this to the volume that we found out. Let us substitute the value for h and calculate. We simplify to make the calculation easier. The right hand side has a square of 7 in the numerator and a square of 100 in the denominator. Hence, r is equal to 7 by 100 or 0.07 meters. Now, we have to find out how much sheet of metal is used in making the cylinder. When we open the surface area of this vessel, we find out that there is a lateral surface area and there is a base, which is a rectangle and a circle. A rectangle for the lateral surface area and a circle for the base. So, metal sheet used is curved surface area plus area of base, or area of rectangle plus area of circle, which is 2 pi r8 plus pi r square. Let us substitute the values and simplify. Let us not calculate the metal sheet used as yet. Now we know that we have wasted 1/12 of the metal sheet, which means that we have utilized 11/12 of the metal sheet. The metal sheet used is 11/12 of the total metal sheet that was required. Hence, the total metal sheet required would be metal sheet used times 12 upon 11. Let us substitute and calculate. Let us look at another problem. The inner diameter of a cylindrical wooden pipe is 24 centimeters and its outer diameter is 28 centimeters. The length of the pipe is 35 centimeters. Find the mass of the pipe if 1 cubic centimeter of wood has a mass of 0.6 grams. So, we have an outer cylinder and an inner cylinder. The space between these two cylinders is made of wood. Let us label our diagram. The height of this cylinder, which is given as the length of a pipe, is 35 centimeters. So, the volume of wood required would be volume of outer cylinder minus volume of inner cylinder, since it is a wooden pipe. So, the inner cylinder is hollow. Pi times capital R square times h minus pi times small r square times h. We can take pi and h common. Let us substitute the values. Look at the bracket. Does it remind you of an algebraic identity? Yes, it is a square minus b square, which can also be written as a plus b times a minus b. Let us apply that. Wow, it makes our calculation easier. Let us simplify. In calculations, it is a good idea to club numbers together that give us easier multiplications. Now we are given that 1 cubic centimeter of food has a mass of 0.6 grams. Applying unitary method, let us recap the surface area and volume of a cylinder. In the next lesson, we shall look at the surface area and volume of a cone.